Hey guys, welcome back to chapter 13. So before we can dive into colligative properties, the last thing that we need to talk about as it has to do with solutions is this idea of concentration. So how concentrated or dilute is a solution. So just quickly, the definitions qualitatively in the absence of numbers. A dilute solution would have a small amount of solute compared to solvent. So I put just a little bit of my solute in and then pour a whole lot of solvent over it. That's as opposed to a concentrated solution where we have a large amount of solute compared to solvent. The silly example that I use for this one is this idea of sweet tea in the north versus sweet tea in the south. So sweet tea in the north would be considered a dilute solution. So you put a little bit of sugar in your tea, and then you pour a whole lot of tea over that sugar. Sweet tea in the south is you put a whole bag of sugar into your cup, and then you pour your tea over that. That would be a very concentrated solution. So you have probably about a 50-50 mixture of solvent and solute. So that'd be a very concentrated solution, sweet tea in the south. Back in Gen Chem 1, we did talk about units for concentration. So you may have seen something like parts per million, parts per billion, percent. But really the one that we focused on was this idea of molarity. So molarity is denoted with a capital M, and it's the moles of solute divided by the volume of solution, and that volume is in liters. So that's and here's the formula. So capital N denotes molarity. N, remember, don't know why they use N, but my brain always says number of moles. So N is number of moles and V for volume, and that's in liters. So this was the unit that we used a lot back in Gen Chem 1. You will see it come up from time to time in this chapter. But what I want to do now is introduce a new unit for concentration, because this is the one that we're going to use in some of our colligative property calculation. So it's a new unit. Let's get to know it first before we dive into colligative properties. So the new unit is molality. I know, not at all confusing with molarity, right? Molality is the amount of solute in moles, so that's the same, divided by the mass of the solvent in kilograms. So instead of saying I've got 4 moles per liter of water, I would say I have 4 moles per kilogram of water. So it's the weight of the solvent. Molality is denoted with kind of an italic or a cursive M. So this is how you'll see me denote it as I write problems. So no, I didn't put an extra little hump in there. That's the cursive for M. I'm going to do my best to italicize it when I use it digitally. So molality equals, again, N stands for number of moles. And then just a regular old M, this stands for mass in kilograms. Okay. So molality. So before we get much further, let's just quickly do a plug and chug problem just to see the calculations with molarity, molality, and I've certainly added a bunch of these into homework and practice problems. So here is our problem. You prepare a solution by dissolving 17.2 grams of ethylene glycol in 0.5 kilograms of water. The final volume of the solution is 515 milliliters. I want you to calculate the molarity and the molality. So this will give us an opportunity to kill 2 birds with 1 stone. Okay. So first thing that I always do with these types of problems is I just take inventory of what I know, what I need to solve for. So I'm going to focus first on molarity. So molarity equals number of moles over volume. Do I know the molarity? No, that's what I'm trying to solve for. Okay. Do I know the number of moles? Well, no. I don't see anywhere in here where it says I have this many moles, but what does it tell me? Yeah. And we are proficient chemists, so we can do a grams to moles conversion very quickly, right? Yeah. So we'll do that. We'll say stay tuned because we'll do that in just a minute. We have the ability to figure it. And then lastly, we've got volume. So does it give us the volume of this solution? Yeah, volume is 515 milliliters. Okay. So before we can plug and chug, first we got to get number of moles. So let's do a grams to moles conversion. So I teach train track method. If you have a method that works for you and it works, you may use that one. But this is the one that you'll see in my calculations. So I'm going to start with what's given. So for every unit conversion problem that ever existed, we write down the information given. So 17.2 grams of this guy. Okay. So draw our train tracks and let our units guide our problem. So the unit that we're trying to get rid of, the unit that we're eliminating, is going to go diagonal. So we have grams on top, and we'll eventually have grams on the bottom, and those two units will cancel. Boop, boop. And what is the unit that we're interested in this case? Well, we're trying to convert to the unit of moles. So that's the unit that's going to go on top. That's our destination. Okay. So now we're set up for success. We let the unit guide our problem, set up our problem. Now we just need to figure out what the heck numbers we need to plug in there. Okay. So remember, this portion of our problem right here is molecular mass. Okay. So we go to the periodic table and we add up 2 carbons, 6 hydrogens, and 2 oxygens. And that's how many grams are in 1 mole of this substance. Okay, so let me do that over here as kind of a side calculation. Carbon, if I look at the periodic table, I look at the number on the bottom of the periodic table, I see 12.011. And in my molecule, I've got 2 of those. Okay, so I'm going to take 12.011 times 2, and we get 24.022. And then I'm going to do hydrogen. So I go to my periodic table, I look at the number on the bottom of hydrogen, and I see 1.008. And in my molecule, there's 6 of them. So 1.008 times 6 equals 6.048. And lastly, I'm going to do oxygen. So I go to the periodic table and I see the oxygen is 15.999. I've got 2 of them in my molecule. So 15.999 times 2 is 31.998. All right, so to get the molecular mass of this whole molecule, I'm going to add these 3 numbers together. So 24.022 plus 6.048 plus 31.998 equals 62.068. And that's how many grams are in 1 mole, grams per mole. Okay. So this is the number that goes over into our unit conversion problem. So in 1 mole of this substance, we're going to have 62.068 grams. Okay. All right, so now my train tracks are set up. I have my units plugged in. I have my numbers plugged in. Now I just need to throw it into my calculator and do my grams to moles conversion. Let's clean up here. All right, so multiply across the top, divide by the bottom. So 17.2 times 1 divided by 62.068. And 17.2 grams is the same as 0.277 moles. Okay. So that's the grams to moles conversion. We learned how to do that in Gen Chem 1. That is your review, so I will not break problems down that much in the future, but hopefully that was a helpful review for you guys. So now we can change this to the number of moles because we calculated it. It is 0.277 moles. Okay. All right, so now that we're over here on the left-hand side taking inventory, I know 2 of my variables. I can solve for 1. So now I'm just going to plug and chug. Plug it into the equation and chug through it. So the molarity of this equals 0.277 moles divided by, am I going to put 515 on the bottom? Nope. What am I going to put on the bottom? This is milliliters. What needs to go down here? Yeah, liters. So convert that, and what you'll see is it's 0.515 liters. Plug this into my calculator. So 0.277 divided by 0.515 equals, and the molarity of this solution is 0.54. And again, 2 ways to do the units. So you could do moles per liter, so just taking the units right off of there. Or you could just write a capital M. So we would read that as 0.54 molar. Okay. So that's molarity. Now I'm going to click ahead. I'm going to do molality. So molality is the new one. Okay. So, oops, I don't have another slide. So I'm going to have to clear this one off. Just kidding. All right. So erase all the ink. Cool. Molality. So molality, not capital M, molality is number of moles divided by the mass of solution, or excuse me, of solvent. So we already calculated the number of moles. That would be the exact same process. So molality is what we're solving for. We already determined the number of moles was 0.277. Okay. And then the mass, it was kind to us here, and it went ahead and just gave us the mass of the water in the correct unit. So the mass here is 0.5 kilograms. So this one's just a simple plug and chug. So the molality of this solution is 0.277 moles divided by 0.5 kilograms. So 0.277 divided by 0.5 equals 0.55 molar. Molal. So you could, again, do the little cursive M, or just carry over moles per kilogram. So again, you have both options. Okay. So that's just a quick introduction and review to calculating the concentration. Molality will be used in our colligative property calculations. So get comfortable with it so that when we add another step in, molality will come easy to you. I hope you guys found this helpful.